Howdy guys, this is Ash.
And I'm Travis.
And today we're gonna introduce a brand new series. I call it Revopoint Case Study.
Wow. So pretty much what we have to look forward to is we're gonna be going over how to use the 3D software, and then after that, how to use the 3D printer. So literally we're gonna start seeing why these things are actually functional. Today we have a special guest with us. His name is Jaco Field, and we're really gonna pick his brain and learn from him because he is a true professional in the 3D industry.
And Jaco, he is from South Africa. Originally, he works as a mechanical engineer. And here he is.
What up?
Okay, so today's mission is we're gonna take Ash's phone here and we're gonna scan it with the purpose of making a case for it. So then put it into the 3D software and then we're gonna print it out through the 3D printer.
You know what, Travis? Normally we call that reverse engineering.
That's the word. We have a little disclaimer here, a good reminder is that Jaco, before he's doing the scanning, he sprayed this, but make sure you have to cover all the holes. Use tape, the plug here, the speaker holes, because obviously you do not want to damage your device.
Yes, guys, and remember to read your instructions of your scan spray before you apply, especially to any electronic device.
And we like to use AE sub spray.
Travis, we don't mention other brand name in the video.
My bad.
Come on.
We like to use different sprays. But also thank you for your sacrifice, Ash, because we're using your phone.
Yeah.
No phones were harmed in the making of this video. So yeah, cool. I mean, I've seen 3D printers before, but this has a different look to it. What's going on here? What is this used for? What is it called?
So this is a resin 3D printer.
Resin 3D printer. Okay.
It uses an LCD display, liquid crystal display, similar to what you would find in your older laptop computers or monitors. What it does is it lights up just specific cells of the LCD in a pattern. Let's say you use this mobile phone, and as it lights up, it solidifies the resin in the specific pattern.
Very interesting. So compared to the other one, this was a resin and the other one has a reel. So what would make you want to choose one over the other when producing a product?
So a resin 3D printer is significantly more accurate depending on the amount of pixels compared to FDM printer. This has a more steady structure, it has lead screws, it is on linear rails, where FDM printer with the reel you mentioned is on plastic wheels and uses timing belts to move the axes around.
Interesting. So you're going to get better detail out of this.
So you get much higher details, up to 20 microns. So that is 0.02 millimeters.
Wow, that makes a difference.
Absolutely.
For instance, what would you want to have for, like we're doing a cell phone case. Does it matter between the two, or do you think this is still a better choice for that?
The resin printer would always give you the highest detail, especially if you want to have a unique pattern on the back side of your phone.
Which we do. We're going to be putting the logo on there.
Yeah.
And what do you personally like working with more?
Personally, I like using a FDM printer. It's safer, it's more hobby friendly, and also it's a lot more affordable than a resin printer.
Okay. And as for families, if you're starting out a hobby person, just getting into scanning, do you think it's better for them to first go with the one on the reel or this?
I would say the one on the reel because it's more user friendly, but depending on the type of scanner you buy, if you buy a Revopoint Mini, it would maybe be better to use a resin printer because you want higher detail. The Mini is made for detail.
Okay.
But if you're going to use maybe the range scanner and want to print something and scale it down, the FDM printer might be your better option.
All right, Jaco, I see that we're one step away from the final printing, which is slicing. But could you tell me what is slicing? Like, what exactly does it do?
To give you a basic understanding, Ash, imagine this mouse is an onion. And if you chop up an onion, it has layers. And with the slicing and printing, it basically takes those onion layers and builds your mouse.
Like piece by piece? A lot of pieces that combines a whole onion or a mouse.
Yes.
Ah, that's why it's called slicer.
Yes.
Got it. And this slicer software we're using is called CHITUBOX.
Wait a second, Ash.
Yeah.
I thought you mentioned that we're not supposed to use other brand names?
That's because, Travis, CHITUBOX is not just other brand, it's the brand we're working with from now on, okay?
Okay, so I can relax.
Yeah, off you go, man.
Okay.
Okay, so, and also about the slicing, I don't understand that, Jaco, you already done a perfect 3D model in the professional software, right? So why we still need to do the slicing?
So the slicing, after it builds your layers, it computes and creates a file known as G-code. Now this G-code is numerical values for the machine to understand which direction should which axis move to build your model.
The numeric coordinates, like XYZ stuff, like,
yes.
I get it. That's pretty complicated though. Hope I can understand.
But CHITUBOX makes it very simple.
So you can use CHITUBOX and CHITUBOX Pro for easy printing. Just a few clicks and man, you don't have to worry about all those complicated parameter settings. But of course, if you want to and if you can always choose to set it all up manually. Like we did for this phone case, CHITUBOX generates supports automatically for me. Cause I got this logo design on the back of the case, so supports is kind of complicated if I do it manually. And it turns out to be very smart, actually smarter than me, but maybe not always smarter than you guys. There are a lot of presettings for me to choose from. To be honest, I don't understand all of the parameters. However, I can understand these presettings. So I just choose what I need. Before I start printing, I'm not very sure what the best position is. CHITUBOX would do the auto orientation for me, and this helps us significantly by reducing mistakes made from wrong positioning. You all know that RevoScan can detect and delete isolation redundant, and so does CHITUBOX. It shaves off unnecessary parts, or let's say redundant shells, so you can get a much cleaner print while maintaining all the details you want. And remember, we always use fill holes function in RevoScan 5, and CHITUBOX can do the total opposite, that is, punching holes in your 3D model. Say, for instance, I want a hole in my phone case to attach a keychain. So, in short, CHITUBOX and CHITUBOX Pro are good for both rookies and pros. It has a wide range of presettings that are good for different applications. It also provides a very professional tool for those pros to get on your complicated projects.
2 hours later.
Hoorah! All right, thank you for delivering us this amazing project, Yaku. So we got kind of several questions for you, okay? So my first question is, Yaku, how do you feel sitting between me and Travis?
Privileged, right? Anyways, but for the real questions now, what made you want to go with using a scanner opposed to a 3D scanner opposed to other methods?
Let me get a prop and then I'll explain to you.
Oh, we love props.
Nice.
So this is a tape measure. I believe everybody knows what it is, or it's a manual measuring tool.
Yes.
And each time you have to manually measure. And then when you want to draw, oh wait, did I measure that correctly? And they say usually measure twice, cut once. With the 3D scanner, it's only scan once. To improve your results, you can simply use tissue paper as a reference, because you might think, wait, that iPhone, it's a normal shape. Should I place markers all over it?
Oh.
You can just use the tissue paper.
That's a nice trick of the trade right there.
That reminds me of my favorite con, but this is another level thing.
Yeah. Even cheaper than Con.
It's an affordable option and it works.
Nice.
Everybody has tissue or toilet paper in their house.
Sounds good. And Yaku, so could you tell me about why exactly we're going in this complete process? Like we're doing the scanning, and when we're doing the 3D designing, which I don't really understand. I call it your sorcery.
Yeah.
And then slicing and printing. So can you tell me what the whole process we're going, why we're doing this, and what exactly we have done?
As with your previous question, it's to avoid unnecessary time spent with manual measurements. So we would scan this iPhone. Now you have a digital mesh file known as a STL. You can import that into your CAD software. You do not have to necessarily reverse engineer it, but I prefer to reverse engineer. Then I have a sleek model of the iPhone. I then would design my case around it. And you do not have to go back and measure again. If you're unsure, you can just go back to your mesh file that's already inside of your CAD software and measure between 2 points.
I get it. And that's exactly why you choose the Revopoint Mini, because Mini got the best accuracy.
Yes,
right.
Very good accuracy, very good detail, and especially Revopoint scanners do not require a beefy, bulky computer. You can even use your mobile phone to scan and process the data.
Nice.
That's a good segue into my next question. Just what have been the benefits of working with Revo 3D scanners opposed to, because you've been in the industry for a while using other scanners, what do you think is the benefit of using Revopoint? Yeah.
So Revopoint scanners are designed like a phone. Imagine, like your phone is not anymore this big chunky thing. It's not heavy, it's lightweight, it's comfortable, it looks sleek, it looks nice. And the Revopoint scanner is lightweight. If you have a big scanner and you're scanning a car, your arm is going to get tired after a while holding the scanner.
True.
Revopoint scanners are about the same weight as what a mobile phone is. You do not have to connect it to main power in the wall. It's powered by either a power bank if you're using your mobile phone, or it directly gets powered from the USB port.
Very good point. Yes. So that makes me curious about, like, before when you don't even have a 3D scanner. Could you tell me the difference? Like, it saves your time, or it just makes you less effort when you have the 3D scanner? Can you tell me what you do before when you doing everything manually?
So at certain points it might not save you time, but it surely saves you effort. Let's say if you want to accurately measure this phone, you would either have to use a vernier caliper, you have to measure multiple angles. If you want to get the height of this camera, you have to fiddle around to get it. Whereas if you scan it with the scanner, it captures all the data, and just with simple few clicks on your CAD software, you can measure between the two planes.
I get it. And the reason you're using that caliber to measure it again, and you just did it once to just make sure, right?
Correct.
Makes sense. So you don't have to, measuring and forgetting and keep measuring and forgetting again.
Yeah, and that just made me think of, can you imagine trying to measure the height of the camera? I mean, you couldn't do it with a tape measure.
No. Well, a caliber can do the trick, but the caliber is not always that easy to use.
And it's not always affordable. Certain calipers are even the same price or even more expensive than the Mini.
Oh, that justifies more to use the Mini then. Yeah.
Wow.
Good point.
And just, you've shared with me in the past, just for those beginner scanners out there, in basic terms, how would you liken a scanner when you're scanning something? You've used like illustration to me before. What's the illustration you used when you're trying to imagine what is the scanner doing? Because it's not like taking a bunch of little pictures, but what are you likening it to?
If I want to explain a visual for what you're not seeing the scanner is doing, imagine you have a paintbrush with wet paint on it and you splat that paint on a wall. There's a bunch of paint dots on the wall.
Dots, yes.
And those dots are then connected, like connected dots in triangle forms. So it forms polygons.
Ah, like a lot of grids, right?
Like a grid mesh, yes. And basically that is what the scanner is doing in the back end, what you're not usually seeing with your eyes visually.
I love that. Yeah, that's good.
Got it.
Because you gotta imagine it, that's helping. You can imagine that as you're going over the object, what's going on, spitting paint out.
Yeah,
visually.
That's very intuitive
Yeah.
though, yeah. Cool. So my last question for today. So do you think, or can you tell me what skill set or knowledge that I am missing? Also, it's like the same to the audience, that you need to do this complete reverse engineering project. For instance, like I don't know how to use that CAD software. It makes me dizzy the first time when I see it. And also the 3D printing. I kind of know how to 3D print a thing, however, using a very CHITUBOX Pro version is also kind of challenging for me. But seems you got the hang of it in a very fast time. So can you share with us your experience and your recommendation?
God, that is one big question. Oh.
Well, you can just tell me in the easy form, like in the outline, what exactly I need to learn.
Okay, what you need to learn. Okay. So for scanning, you can just imagine it as a video camera, but instead of moving fast, do not think your scanner is an action camera. Try and make it as smooth as a B-roll. For the viewers, what a B-roll is usually that slow close-up shot that you see in an advertisement. Yes.
Like this.
Because sudden movement would either cause misalignment, your scan would be inaccurate, and slow movement would give you more assurance that your scan would be correct. So now you've got that down, you have to be creative with your mind, like with the tissue paper, to use this as a tracking reference. If something is plain, like a couch, add an extra pillow or two, or put a blanket there. That would help you with tracking if you don't want to place markers on it, especially if you're using an instrument that you don't want to damage. You can just place something around it.
And for us lazy people, that's nice, right, Ash?
Yeah.
Yes, you do not have to clean up afterwards with the markers. You can simply just throw the tissue paper away. So that's that part. For the CAD software, there's no easy way around that. You have to actually learn and understand how to make sketches, because you make a mechanical sketch, or it's similar to manual mechanical drafting. You're just making that 2D sketch or 3D sketch on your computer screen and simply extruding from that and using your mobile phone scan data as a reference. For the slicer, you're in luck. There is a major, huge community on YouTube that uses 3D printing slicers, and especially CHITUBOX has very good user manuals.
Great. Okay.
And I'm just curious, what got you into this industry? Were you naturally, as a teenager, were you pulled to this, or was it like something you fell into, or how did you start?
I don't know how you two were as little kids, but I used to take everything and disassemble it because I wanted to know what makes this thing go back.
Oh.
So I have an inquiring mind. I want to know what makes the thing work, so I would always break it. And see how it works.
And sometimes when you break it, you can't put it back together, right? So
Absolutely.
You would need a scanner.
You would need a scanner to make a replacement for the part you broke.
Got it. Oh, that's so nice. Well, thank you very much, Yeko, for today's amazing project again. Yeah. So We will see you next time.
Bye-bye.
Bye.